Hello children, welcome to Zero Panic Maths. So in today's session, let us continue our discussion on the concept of distance between the 2 points in the 2D plane. Okay, so in the previous session, we have discussed the introduction on the use of coordinates and what is a two-dimensional coordinate system is, and we have even solved some of the exercise problems also in the previous video. Okay, so if you have not watched that video, so before you start watching this video, I suggest you to please watch that video. Okay, the link is given in the description. Okay, now let us continue our discussion on this concept today. Okay, so it says the distance between the 2 points in the two-dimensional plane. Okay, now how do you find the distance between the 2 points? In the previous session, if you remember, we have found out the distance between the two coordinate points, but those coordinate points were either parallel to the x-axis or parallel to the y-axis, and the lines will be parallel to either y-axis or x-axis. One of the coordinates value will be 0 in that case. So just subtracting the x or y coordinate values was giving us the length of the or the distance between the two coordinate points. But as given in this case, if those were not parallel, those lines are not parallel to x-axis. So you can see here there is a triangle AMD, and the coordinate points A and D, they are not parallel to either x-axis, y-axis or x-axis. Any of these lines, okay, there are three lines which are making a triangle here, but none of the lines are parallel to x-axis or y-axis. Now in this session we are going to see how do we find the distance between such coordinate points which are not parallel to any of the two given axes. Okay, now how do we do that is given, shown in the next slide here. You can see, simply just concentrate here. So it was the same triangle that we saw in the previous slide. Okay, so the point A, there is a triangle ADM. Now suppose, now just concentrate on this. I am trying to find out the length of AD. Okay, now for that what they did is, see, the distance moved along the x-axis is given by CD. So if you make a point C here, an imaginary point C, and draw two parallel lines, draw the two parallel lines, making this as a 90-degree or a right angle triangle ACD. Now that we have a right angle triangle ACD, okay, right angled at C, okay, so what we can do here is we can first find out the length of CD and length of AC. And how did we find the length of AC and CD is by this way. Okay, so you can see that the distance moved along the x-axis is given by CD. This is CD and this is the distance moved along the x-axis. And how do you find out CD? Is x coordinate of D minus x coordinate of A, which is actually 3, right? D minus 3. See, D7, which is 7, minus 3, which actually gives us 4. That is 1, 2, 3, 4. You can see that 7, which is x coordinate of D, and 3, which is x coordinate of A. So I am finding this distance. And similarly, the distance moved along the y-axis is measured by AC. Okay, this is measured by AC. And how do you find out the AC? Is y coordinate of A minus y coordinate of D. Correct? See, y coordinate of A minus y coordinate of D, which is 4. 4 here minus 1, and this will give me 3. Right? 4 minus 1 is equal to 3. Okay, now that I have the value 4 distance for this and 3 for this, can I find the value of this AC? Exactly the length of AC I can find it out, because by applying the Pythagoras theorem we can get the distance AD. And how do you find out the distance AD? Is by square root of 4 square plus 3 square, that is AC square plus CD square is equal to AD square. That is according to Pythagoras theorem. So what is this? Then AC square, that is 3 square, which is 9, plus CD square, which is 4 square, and that is equal to 16. And what is this? It is, you can say, square root of 25, and that is 5 units. Square root of 25, that is 5 units. Now similarly you can do it for this and this also. How do you do that? How do you do that? By just creating the imaginary lines over here. You got this point? So this is a right angle triangle. You need to find out this. What is this? 1, 2, 3, 4, 5, 6. Or else you can say x coordinate of m minus x coordinate of a. That is 9 minus 3, which is 6. Again, y coordinate of m minus y coordinate of a. That is 6 minus 4, which is 2. Correct? So 6 square plus 2 square, square root of that will give me this. What is that? AM. Okay. Similarly, that RMA. DM. How do I find DM? Here. By creating a imaginary right angle triangle here. Okay. And finding out this distance. What is this distance? Which is 2. Or you can say that is the x coordinate of m minus x coordinate of d, which is 7 here. Okay, d7, or else you can see that d7 it is. Okay, so 9 minus 7, that is 2. So this distance is 2 for you, and this is 6 minus 1, that distance is 5 for you. You can see that 1, 2, 3, 4, 5. Okay, so similarly I can say that dm. How can I find dm? Is square root of 2 square plus 5 square, that is 4 plus 25, that is square root of 29. Okay, you don't have to resolve it, but you can find out the value of that. Okay, ma, what is ma is square root of 6 square plus 2 square. Correct? Square root of 6 square, which is 36, and it is 2 square 4, you can say square root of 40. Okay, this is how you will find out the distance between the any two given coordinate points by drawing a right angle triangle, imaginary right angle triangle, and making the line for which you want to find out the distance as a hypotenuse, and so that you can apply the Pythagoras theorem directly and find out the exact distance between the two coordinate points, any two given coordinate points. Now how do we generalize this and find a formula? Because all the time we cannot keep on drawing this imaginary triangles and find out, apply the Pythagoras theorem and find out the value. All the time we cannot keep on doing this. Okay, that's why we will generalize this and find out a formula on that. Okay, so how do we do that is given in the next concept. See, listen to me carefully. This is very important. Okay, now assume that there is a coordinate point A with x1 and y1 as xy coordinates, and there is a coordinate point D with x2 y2 as the coordinate points. So, and you are drawing the imaginary line here, so that you will find out the x1 as, see, when it is x2, x1 is this one, x1 is this point. Say suppose this is the f point, whose coordinate points will be x1 towards the x coordinate and y2 towards the y coordinate. It will be always like that only. You can see that in the previous example only I will tell you this. See, 7 minus 3 is getting you 4. Okay, so and where are you taking the 3 from? It is x1. It is x1 y1 and it is x2 y2, so it is x1. So C, the point C will be like this. It will be x coordinate from the first point and y coordinate from the second point. It will be like this. That is the reason you are getting this. You got my point? You see that 4 minus 1 is 3 and 7 minus 3 is 4. So that's why this point is always x1 y2. Okay, and that is given here, x1 y2. You understood this? Okay, now how are we doing this then? So this distance will be, if you are apply the generic rule of finding the distance between the two coordinate points which are parallel to x-axis and y-axis. Okay, apply that rule. Applying that rule uh, will give you, see, since it is y2 and y2 here, that will give you 0 only. So it is x2 minus x1. Only x coordinates are subtracted here. So it is x2 and x1. So what is this distance? Will be x2 minus x1. Correct? Similarly, here also, you see, you just ignore the x1 x coordinates because it is x1 here. You will ignore the x coordinates, and what you will do is y2 minus y1 will give you the distance. It does not matter whether it is negative or positive. Okay, x2 minus x1, because we just want a distance. We just want a distance and not exactly the difference. Okay, it is not the subtraction from y1 minus y2. It is not that subtraction, it is the difference between the points y1 and y2. So it can be y2 minus y1 also. Okay, anyway, when it is squared, even the negative number will also give you the absolute value of the given result. Okay, so we generally we consider this distance as x2 minus x1 and this distance as y2 minus y1. So now by applying the Pythagoras theorem, what it will be is square root of this. Suppose this is a and this is b and this is c, suppose that. So what will be the Pythagoras theorem? It will be like c square is equal to a square plus b square, right? This is the Pythagoras theorem. Suppose this is c, this is b, and this is a, and in that case, what is c? It will be square root of a square plus b square, and that is what we are doing here also. Okay, if you are getting confused, you see that what is a is x2 minus x1, and what is b? B is y2 minus y1 and the square of those two. So in generally, for any two given points, in general, the distance between the 2 points x1 y1 and x2 y2, where x1 y1 and x2 y2 are the coordinates of first point and second point respectively, then the distance between these 2 points is in generally found by this formula, and that formula is square root of x2 minus x1 whole square plus y2 minus y1 whole square. Remember this formula. This is going to be the formula that we are going to use for solving the many of the problems in the coming exercise. Okay, you understood this clearly? Okay, let us see. Okay, now we have done with the concepts. Now we will see the end of chapter exercises. They are asking what are the x coordinate and y coordinate of the point of intersection of the two axes. Okay, this one we have studied in the very beginning of the chapter, that if there are two axes, okay, considering these two axes are two number lines, then suppose this is 1 2 3 like this, and minus 1 minus 2 like this. There will be 1 2 3, and there will be minus 1 minus 2 like this. Two number lines, one vertical and one horizontal. When they meet together, and this point will always be equal to 0 for x-axis and 0 for y-axis, because there will be one coordinate 0 vertically meeting and one coordinate 0 which is horizontally meeting. So that the answer is 0 and 0 are the x coordinate. X coordinate is 0 and y coordinate is also 0. This is a simple question. Okay, let us move to the next question. So now next question says the point W has x coordinate equal to minus 5. Okay, now listen to me carefully. This is very important, very interesting also. Okay, now we have the point W has x coordinate equal to minus 5. Now assume this is the graph, and we are pointing out one coordinate point W whose x coordinate is minus 5. Can you predict the x coordinate of can you predict the coordinates of point H which is on the line through W parallel to y-axis, okay, now suppose this is x coordinate and this is saying see, anywhere here they have not given the y coordinate of w they have not given, but they have given, you have to listen carefully, but they have given h which is parallel to, h will fall in line with y coordinate, in line with parallel to y coordinate, and suppose anywhere here on this line w might fall because it is -5, only x coordinate they have given -5, and there is no y coordinate given for that. Okay, and they are asking h might fall anywhere on line. See, predict the coordinate of h which is on line with through w parallel to y axis. This is parallel to y axis, this line is parallel to y axis. Are you getting this? Okay, now which quadrant h can lie in? They are asking us which quadrant h can lie in. So h either lies in second quadrant or third quadrant, because it depends on what is the value of h. What is the value of h? So see, since the point w has x coordinate value has -5, I've given the answer also here, I'm not going to write it. Okay, and the point h assumed to be on the line parallel to y-axis. See, it is parallel to y-axis, so the point should be like this. Point should be -5y. We don't know the value of y, where y is any real number. Y is any real number. It can be plus 1 2 3 4 5 minus 1 2 3 4 5, like that. Okay, since the x coordinate is negative, because it is already given as negative, I am drawing this line here. Okay, it is given as -5. So if y is greater than 0, it says if y is greater than 0, then it is in the second quadrant, the h lies in. Or if y is less than 0, then it will lie in the third quadrant. And if y is equal to 0, then it will be on the x-axis. It will be on the x-axis, not in any of the quadrants. This is what the answer for this. Understood this? Okay. Now let us move quickly to the next problem. Okay. Now let us see what is asked. Okay. Consider the points R30, A0 minus 2, M5 -5 minus 2, and P -5 2. There are four points given. If they are joined in the same order, predict the two sides of RAMP that are perpendicular to each other. Okay, now let us first point out those lines and join those to create a geometric figure first. Okay, R30. Okay, 3 towards x-axis and 0. This is R then. This is R30. It says y-axis 0. So it is R30. Okay, a 0 minus 2. Okay, so they are saying 0 x-axis and -2. This is a, this is a 0 x-axis -2 y-axis. M -5 -2, both the coordinates are minus, so it is third quadrant. -5 -2, it is -5 -2. And what is this? What is this? M is -5 x coordinate and -2 y coordinate. And finally -5 2, which is p, -5 to the positive side of y-axis, that is p -5 2, -5 2. Okay, now join. If they are joined in the same order, okay, let us join. This is R A M P, correct? Okay, let me join this also. RAMP, RAMP. Okay, now as you can see here, since x coordinates of P and M are -5 -5, I can say this is a right angle. That is the answer to the first question. See that carefully. What they are saying, two sides of RAMP that are perpendicular to each other. So here PM is perpendicular to AM or MA. You can write the answer as PM is perpendicular to MA. This is the answer for this. Answer for the first question. Okay. Second question. one side of RAMP that is parallel to one of the axis. Okay, so you can see that there are two such sides which are parallel to the other axis. See, PM is parallel to y-axis and MA is parallel to x-axis. You can write those also. The answer for this will be, there will be two such sides. PM is parallel to, this is perpendicular symbol and this is parallel symbol. Okay, PM is parallel to x-axis, or you can write MA is PM is parallel to y-axis, right? It is not x-axis. PM, this is parallel to y-axis. MA is parallel to x-axis, or you can write MA is parallel to x-axis. This is the answer for the second question. Okay, simple. Third question, two points that are mirror images of each other in one axis. Which axis will this be? Mirror images means if you see these 2 points P and M, you can see it looks like a mirror for x coordinate. It is -5 here, -5 here. Okay, but since they are mirroring the x-axis, see, listen carefully. If you consider x-axis as a mirror, it actually shows -5, -5 in the mirror. So the 2 points that are mirror images of each other are P and M. Okay, so the answer is P and M are mirror images because x coordinate is same. You cannot have both the coordinates same. Okay, so only x coordinate is same, that's why it is mirrored in x-axis. Okay, P and M are mirror images uh, with x-axis, you can say. This is the answer for this. So x-axis is acting like a mirror here. X coordinate values are looking similar, okay, in both the coordinates. Okay. Okay, now we are moving to the next problem. Problem number 4. Plot point Z 5 minus 6. 5 minus 6 on the Cartesian plane. So I'm considering this as an example of the plane. Construct a right angle triangle IZN and find the lengths of the three sides. Okay, now let us first plot the point Z 5 minus 6. Okay, 5 towards the x-axis and -6 towards the y-axis. So that will be 5 and -6. So this is that point Z. This is that point Z, which is 5 minus 6. And they are, what they are asking, construct a right angle triangle IZN. See, the answer for this question differs based on how do you construct the right angle triangle. Now suppose if I see, considering Z as one of the point, see, if I draw I here, okay, as 0 0 as one of the coordinates and ZN here, okay, say suppose N, this is IZN. They are asking us to plot a right angle triangle IZN, right? So N, what is the x coordinate of this? Is 0 and y coordinate is -6. Suppose I assume the right angle triangle like this, and if I draw the right angle triangle like this, suppose this is the right angle triangle, right angled at point Z, point N. Suppose this is the right angle I try. So then the values of all these sides, they are asking lengths of all the three sides to find. So in such case, the lengths will be different. But if suppose instead of considering I here, if I consider I here and draw the hypotenuse like this, the lengths might be differing. So the answer for this question differs based on where do you point the coordinate point I, whether it is here or here. It depends on that. Okay, so I am considering I as a origin point 0 0 and making a right angle at point N. Now you can for your practice purpose, what you can do is consider I at a point here, okay, 5 0 as the I point, and draw the hypotenuse from here, making a right angle at Z, and try to find out the lengths. Okay, that is a practice purpose for you, and it will be a different alternative answer for the same question. Okay, let me take this as a right angle triangle and find out the lengths by applying the formula that we have derived it in general. Now I can say considering triangle IZN right angled at point N, right? Point N. Okay, and the coordinate points are 0, -6. You can say 0, -6. Now find out the lengths of all the three sides of this given triangle IZN. Okay, with I 0 0 and Z 5 6. Okay, sorry, I'm sorry. It is not 6. It is -6 actually. Okay, it is in the fourth quadrant where Y coordinate will be -6, and already it is given as -6. Okay, sorry about this. I have missed it. It is -6. Okay. Now find out the distance between IZ, that is IZ is equal to square root of, we are going to use that formula, x2 minus x1 whole square plus y2 minus y1 whole square, that we have found just in the previous slide. Okay, so what is x2 here is 5 and x1 is 0, y1 is also 0 and y2 is -6. Okay, so it will be like 5 minus 0 whole square plus y2 is -6, -6 minus 0, that is -6 square. Okay, so it will be 5 square, which is 25. Okay, and -6 square, which is 36. Okay, it will be 61 units. 61 units, you can write it as 61 units. Okay, now similar to that we have to find the length nz, where x1 y1 are 0 -6 and x2 y2 are 5 -6. Okay, now let us consider that also, nz. Okay, nz is equal to square root of 5 minus 0, 5 minus 0 whole square plus y2 is -6, y2 is -6 and y1 is also -6, but we are subtracting it, so it will become y2 minus of -6, which will be +6. Okay, I'm writing this directly, +6 whole square. So +6 -6, it will be 0 only, and it is 5 square, which is root of 25, which is 5 units, which is 5. Okay, now what are we left with is the distance between IZ, or the length IN, sorry, IN. Okay, here also x1 y1 is 0 only and x2 y2 are 0 -6. Okay, now see IN, I can say IN is equal to square root of 0 minus 0, which is 0 square only. Okay, plus y2 is -6, y2 is -6 and y1 is 0, which is -6 square, which is +36, and it is 6 units. 6 units is the length of this, and this is 1 2 3 4 5. Here also in the figure itself you can see that 1 2 3 4 5 is the 5 unit is the length of this, 6 is the unit of this, and this is square root of 61. Whatever you get, that is the length of this IZ. That is what the answer for this question. Now let us move to the next problem. Okay, next problem is, okay, now I have given the answer here itself, because this is something like a descriptive answer. Okay, so what would be a system of coordinates be like if we did not have any negative numbers? Okay, now the coordinate system that what we have studied till now has both positive and negative numbers towards the x-axis and y-axis, or horizontally, vertically. We have both type of numbers. Now they are asking a hypothetical question that what would be the coordinate system if there are no negative numbers, if there are no negative numbers. So if there are no negative numbers, only the first quadrant will be there, right, wherein both x and y coordinates are positive only. There will not be the other three coordinates, because in any other three coordinates, one of the coordinate value will be negative. So with this system will allow us to allocate all the points on a 2D plane. No, all the points we cannot display, because the points with minus y coordinates we cannot point on that such a coordinate system where only positive numbers are allowed us to positive numbers are available on the plane. We cannot point all the numbers. So answer is, if we don't have negative numbers on the coordinate system, then we will have only positive x-axis and positive y-axis values only. So the points in the first quadrant, only the first quadrant, this is quadrant 1, right? So only first quadrant are possible to locate, and no other quadrant points are allowed to locate in the 2D plane. Is it not? Say suppose if it is asked to point 2 to 2 with minus x-axis. No, minus, because there is no minus coordinate available. Assuming you don't have all the three coordinates, only this coordinate is available. How do you locate this minus 2? 2? It is not possible. Okay. So that is the answer for this question. Okay. Now let us see what is the next question. Okay. Next question is about a different formula. Okay, we will see this problem and the remaining other problems of exercise, the end of chapter exercises in the next session. Okay, thank you.